So now we need to look at entropy in the third way, which is the microscopic treatment, which is basically a statistical or a probability way of looking at the outcomes of throwing dice or throwing heads or tails. So the second law of thermodynamics, which is the one of entropy, as the universe progresses with time, entropy must increase. In other words, the degree of disorder must increase. We are always moving towards a state of greater entropy. So the greater the entropy, the more ways, the more disorder, and it's more likely to happen. So let's take throwing 2 coins, for example. This one's quite easy. There are 4 possibilities. You can have a heads, 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 tails, tails, heads, tails, tails. 4 outcomes. There's one way of getting 2 heads. There is one way of getting 2 tails. But there are 2 ways of getting a head and a tail. And we can do it as a tally chart like this. Now, the number of combinations that you can get for each choice is called the number of microstates. For example, there are 2 ways of getting a head and a tail. So in other words, there are 2 microstates. So there are more microstates, which means there's a greater entropy. So it's more likely to happen. So if you throw a head and a tail, it's twice more likely that you're going to get a head and a tail than you are going to get a head and a head, for example. With a chessboard, let's say you throw a coin on here. How many possible ways are there for that to happen? Well, there are 64 possibilities, 64 microstates of organizing one coin on a chessboard. If you put more particles there are many more ways of organizing 4 particles, many more. So the entropy is going to be greater. The more particles you introduce, the greater the entropy, the greater the possible disorder. Also, another way of looking at it is that if you have the same number of coins but reduce the space, so we only have 4 possible options here, you put 1 coin there. There are only 4 microstates here. There's a bottom left, top right, bottom right. So with a small volume, in this case we've got 1 coin, there are 4 microstates. If we have 2 coins, then we have many more possibilities. There are 4 microstates with 2 on each square, but there are 12 microstates with where they're on separate squares. And you can try that out. Now we need to look at the entropy formula. S is equal to Kb log of omega. S is the value for the entropy. Kb is a Boltzmann constant, which is a very small number, which means that normally we're doing with the log of a very, very large number. So we're multiplying by a small number to get the entropy. Ln is a natural log, and omega is a number of microstates. So you might be asked to do a calculation of this nature. Let's look at another entropy example. This time we look at 3 coins. So let's we have 3 coins, and these are the possibilities: heads, 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 tails, and so on. There are 8 possibilities for this. So if we can compare what's the likelihood of getting 2 heads and 3 heads, we know that if we have 2 heads, it's either going to be heads, heads, tails, heads, or tails, heads, heads. So there are 3 possible microstates where omega is equal to 3. That's for getting 2 heads. Alternatively, so the more microstates will give us a large entropy. If we try 3 heads, what's the possibility of that? Well, there's only one way that can happen. That's heads, heads, heads. So the only possibility is there's 1 microstate, so omega is equal to 1, which means a lower entropy. So if you were to calculate the entropy, you would use a formula. S, the entropy is equal to Kb, which is a Boltzmann constant, times by the log of 3, and that gives you a value of 1.099 because of the 3 possibilities. This is of getting 2 heads. That's why it's got omega 2. Compared to the possibility, the entropy for 1, is S equal to log of 1. Now the log of 1 is equal to 0. So an entropy of 0 means there's absolutely no disorder. There's only one possibility, absolutely no disorder. There's only one possible outcome, and that's the only one it can be. So of course K is a very tiny number, and the entropy is to do with the number of quanta of energy or particles and that's going to be in their millions. So yeah, we'll do some examples of calculating S.